Hello everyone. Welcome to Pace Digital Hyderabad. This is Charita Tittakavi. Today I am going to take you through the chapter Permutations and Combinations, which we have already completed 4 classes of that. Right? So we completed 4 lectures before that, and now we are stepping into the 5th lecture. And what is the topic that we are going with? Sum of all the 5-digit numbers formed by the given 5 digits. See, suppose if I have a number like 321, right? So what are all the possibilities? 312, 123, 132, 213, 231. If I am adding all these 6 possibilities, if I'm adding all these 6 possibilities, what is my answer? That is what I'm going to do. Now, as it is a 3-digit number, we can do it very easily because it is 3-digit number. 3 factorial ways of numbers is what we get. That is 6 numbers is what we get. 6 such combinations. Adding 6 numbers is very easy for us. Right. Now, when I'm talking about a 5-digit number with 5 digits, right? So, obviously, when we have 5 digits, so we will get how many numbers there? So 5 factorial, that is how much? 120 numbers is what we are going to get. And how are we going to add all these 120 and give the answer? For this, we have a simple reasoning behind that in permutations, right? So what is that? Let us just quickly deep dive into this concept, right? So beautiful concept to understand. There are altogether 8 types in this, I would say, right? 8 types, all different formula, everything looks alike. Please do not get confused. If you are going with your perfect presentation of the concept, you will not forget that, right? Now let us start with the first type. What are all the types? Let me tell you. The first type is I am just trying to bring out 5-digit number from the given 5 digits, right? 5-digit number from the given 5 digits. I am talking about without repetition case, right? Next, type 2 is getting a 3-digit number from the given 5 digits, right? You are bringing some 3 letters or 4 letters from the given 5 letters, from numbers actually, right? Now the third type is, this is without repetition, right? Now there is a case with repetition also. So with repetition, trying to get the 5-digit number from the given 5 digits, and type 4 is 3-digit number from the given 5 digits with the repetition. These are 4 done, right? Now where are the remaining 4 cases, right? It is like when 0 is included and when 0 is not included. Now, all these 4 cases is what I have discussed when there is no 0 in my given set of numbers, right? When there is no 0 in my given set of numbers, like 3, 2, 1 or 1, 2, 3, 4, 5. These numbers, if I am giving you, when there is no digit 0 in my given numbers, these are the 4 combinations that I get. Now, with the same set of without repetition and without repetition, if I have the 0 to be included in my number, suppose if I am giving you 1, 3, 4 and 0, I am giving you totally 4-digit number. So how am I going to crack this? Without repetition and with repetition. That is again 2 cases there and 2 cases here, all together 8 cases. So remembering 8 cases like formula is very tough to maintain that. But when you understand the concept and go through the concept, then it becomes very, very easy, right? So now let us start with the concept. Right now, my thought, the type 1, the sum of the 5-digit numbers formed from the given 5 digits, and I am going to give you the numbers or the digits 1, 2, 3, 4, 5. Now, from these 5 digits, I need to frame 5-digit numbers in such a way and find the sum of all these numbers. 120 numbers will be formed. I need to find. So how am I going to do that is, so first of all, what I need to think about is, what is my thought process for the question is, see, for any such combination of numbers, let me take this. So 1 is in units place for these 2 numbers. Then I will add these 2 first. Right? How many other combinations I get, all those numbers I will add. So that is a contribution from 1 as units place. Now when 1 is in the tens place, its value becomes 10, isn't it? So how many such numbers I will be having where 1 is in tens place? I will add all those numbers. Next, when 1 is in hundreds place, what is its combination, right? What is its contribution to the given number, right? So see, when I have the numbers like 232 plus 234 plus 430 or 456, whatever it is, when I am adding this, what should I think is 2 in hundreds place, that is 200. 3 in hundreds place, that is 300, plus all these such numbers combinations is what we will be getting, right? So we need to think about each and every digit, where is its position located, and to that positions what is the contribution made by that number to our total count. That is what I have to check now, right? Now let me go with a digit 2. Let me talk about a digit 2. Suppose 2 is in units place, let it be. Okay, 2 is in units place. When 2 is in units place, how many such numbers do I have here? There is no repetition here. My question is no repetition case. Okay, na? When there is no repetition, see, I said 2 is in my units place. Now, the remaining 1, 2, 3, 4 digits can be anywhere. That is all my 4 factorial, right? So, what is the contribution from 2 in units place is, that is 2 into that 4 factorial. Now let me have 2 in my tens place. When 2 is in the tens place, what is its contribution? That is 20, isn't it? So 20 into, obviously the remaining 4, that will be 1, 2, 3 and 4, that is done in 4 factorial ways. Next come to hundreds place. Now 2 is in my hundreds place. Now obviously the remaining 2, that is 200 into 4 factorial ways of representation. The same with 2 in the thousands place, right? That will be my 2000 is the value, and the contribution is, we have 2000 in the place, and we have 4 factorial such numbers, right? Now 2 is in the 10,000 place, 1, 2, 3, 4. So obviously 20,000 into 4 factorial. Now when I'm adding all this, how do I add all this? It is just addition of all this is my total count of 2's in my given number. Contribution from 2. From 2, what is the total contribution that I get? That is 4 factorial if I take common. If I add up all these, 2, 2, 2, 2 and 2. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes. So 5 places, 5 twos is what we got it, right? Now the same way, what will be the contribution from 1? Obviously it is 4 factorial into 1, 1, 1, 1, 1. What is the contribution from the digit 3? It is again 4 factorial into, yeah, just a minute. Yeah, 4 factorial into 3, 3, 3, 3, 3. Now digit 4. Again 4 factorial into 4, 4, 4, 4, 4. Now coming for the digit 5. That is 5 factorial into 5, 5, 5, 5, 5. Did you understand? So from each and every digit, contribution from each and every digit from their respective places, that is from units place, tens place, hundreds, thousands and 10,000s, all this taken together, all this put together will be the sum of all the 5-digit numbers that I am talking about, right? So when I am adding all this, what do I get? Now adding all this, what do I get? Sorry, this is again 4 factorial, right? So it's a 4 factorial into, can I just take, when I remove 2 common from this, it is 2 into 1, 1, 1, 1, 1, isn't it? When I just remove 3 from this, 3 into 1, 1, 1, 1, 1, 4 into 1, 1, 1, 1, like that. So if I go with that, now it is again, now I am talking of 4 into 1, 1, 1, 1, 1. How many ones? 5 ones. And I am left with 2 plus 3 plus 4 plus 5 plus 1. Right? This is all what I have. So what do I say? This is same as writing 4 factorial into 1, 1, 1, 1, 1. How many times? 5 times into 1 plus 2 plus 3 plus 4 plus 5. The sum of all the digits, right? Now, when my question is a 5-digit number, this is fine. I cannot keep doing with the 6-digit number, 7-digit number like this, right? So, in general, what is a general notation that I have to consider here? So, in general form, if it is n-digit number, From the given n digits, what is my answer? My answer will be, see, when I have 5 digits, my answer is starting with 4 factorial. Hence, when I have n digits, my answer will be starting with n minus 1 factorial. And then 1, 1, 1, 1. How many such ones do I have? When it is 5 digits, I have 5 ones. Hence, I have n digits and I will have n ones. So 1, 1, 1, 1, 1 repeated n times, and into, this is nothing but sum of 1, 2, 3, so on till 5. That is all your sum of all the digits, sum of all the digits taken there in the question, right? So this is my general form of sum of all the n digit numbers formed from the given n digits, right? Suppose if my question is a 7 digit number, right? So obviously you'll have to start with 7 minus 1, 6 factorial, 6 factorial into 1, 1, 1, 1, 1, 1, 1, 7 times. Suppose all my digits are 2, 1, 3, 7, 4, 6, like this, okay? And 8, 1, 2, 3, 4, 5, 6, 7 digits are there. So it is just sum of all these digits will be my answer there. Okay, understood the applicability of this? That is my type 1. Right? Now I am going with type 2. Whoever didn't understand, please rewind back again and check once again, right? Now going with the type 2. Type 2 is what I said. This is the sum of 5 digit numbers without repetition. Type 2 also without repetition only, but I am choosing some 3 digits from the given digits, given 5 digits, right? So that will be my type 2. Right, let me go with the type 2. Right. Now this is the question, sum of all 3 digit numbers formed by the given 5 digits. That's what I'm giving you 1, 2, 3, 4, 5. I need to frame a 3 digit number from the given 5, right? So now suppose if 3 is there in the first place, that is ones place, what is the contribution of 3? And these two remaining 2 digits can be occupied in 5p2 ways. Oh, no, 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 4p2, isn't it? We have remaining 4 digits, that is 4p2 ways. So that is 3 into 4p2, right? Now coming for the, when 3 is there in the tens place, suppose if I have 3 here, right? So here also this place and this place, we have 5 digits for the given 2 place. We have 4 digits for the given 2 places. So that is again contribution of tens place, 3 will be 30 into 4p2. Next, hundreds place. Suppose if 3 is in the hundreds place, that is, suppose if it is 3 is here, the remaining 2 places, obviously 300 into 4p2. Right. Now, this is the contribution of 3 in all the places. Now, what is it? That is 4p2. When I add all this, that is the whole contribution of 3 is what I get. That is 4p2 into 3 plus 30 plus 30, 300. Right? So, that is 4p2 times 333 or 4p2 times 111 times 3. This is what I have. This is the contribution from 3. The same set, we will be getting the contribution from 1, from 2, from 3, from 4 and from 5, right? So, sum of all the such contributions, from all the 5 digits is like you will be getting a 4p2 and 111 taken common, you will be getting 1 plus 2 plus 3 plus 4 plus 5. The same story repeats for all the given digits, that is 3 in the units place is what the story which we have completed now. Next story will be I will take 2 in the units place, 2 in the tens place, 2 in the hundreds place. Next story I will be taking 4 in the ones place, 4 in the tens place, 4 in the hundreds place. Like this, I can write each and every digit story and I'll add all these stories. Right. Now what do I get? Now, this is the answer for the given question, sum of 3 digit numbers formed from the given 5 digits. Now, if my question is from the given n digits, sum of all r digit numbers formed. R digit numbers. So out of the given 5, I have picked only 3. Now out of the given n, I am going to pick only R. So what will be my sum if I am doing this? Now in general, if at all I have to write the formula. See, when I have 5 digits, I started with 4. So obviously, when I have n digits, I will be starting with n minus 1. P, when I have to pick 3 digits, I have written 2 here. So pick R digits, I will be writing R minus 1. Now, how many digit number is what I am taking? 3 digit number, hence 3 ones. So obviously R digit number 1, 1, 1, 1, so on repeated R times. Next here I go with sum of all the digits given there. Clear? Understood? Right? So this is the formula for finding sum of all the 3-digit numbers formed from the given 5 digits, or R digit numbers formed from the given n digits. That is my type 2, right? Now let us quickly go with the type 3. This type 1 and type 2 is without repetition, no digit to be repeated again. Now coming up with the type 3 and type 4 will be the types with the repetition what I am going to go with, right? Right, now coming for the type 3, sum of all the n digit numbers formed from the given n digits when 0 is included and there is no repetition allowed. Here I am including a 0 without any repetition. See, observe 0, 1, 2, 3, 4, 5 are the given digits for us, right? Now tell me, if at all, the same kind of story begins. If my 3 is in the, now the contribution of each and every term is what I am writing, okay now? Now, contribution of 3 in the units place. 3 in the units place. Everyone keep telling me. 3 in the units place, that is a 3, right? Into how much? Now, I have fixed already 3. No repetition allowed. I am left with 1, 2, 3, 4, 5. 5 places, 5 digits, right? So, obviously it is 5 factorial. But I have 0 included in my count. Is it 5 factorial minus 4 factorial is what I will be considering there? Right? Do you remember yesterday's class? We have done this. When 0 is already included in that, or you can also call it, like 3 in the units place, hence its value is 3. And the remaining 5 digits can be occupied by 5 people. When 0 is included, it is actually 5p 5 ways. But when 0 is included, remove 1 less there and 1 less here. 1 less here and 1 less here. So that is your 4p4, or simply you can call it 5 factorial minus 4 factorial there, right? Now when I'm talking about 3 in the tens place, right? Same story, 3 in the tens place, that is 30 into again 5 factorial minus 4 factorial. Now 3 in the hundreds place, which is 300 into 5 factorial plus 4 factorial. Now 3 is in thousands place, that is 3000 into 5 factorial plus, sorry, minus 5 factorial minus 4 factorial. Here also I have to take a minus there, right? Okay. Now again 3 in the 10,000s place, that is 30,000 into 5 factorial plus 4 factorial, right? Now talk about, we have a 3 in the first place, right? That is my 1 lakhs place. Now tell me, how many values will I get? See, why did I take 5 factorial minus 4 factorial? Because my units, my beginning place cannot be 0. Hence, I have to remove few cases. That is what all these cases what I have removed, right? Now, but when my 3 is in the first place, my 3 is there. That is 3 is in lakhs place. 1, 2, 3, 4, 5. Yes, its contribution will be 3 lakhs. Into what do I get? My 3 is here. I am fixing a 3 in my first position. Rest all can be any digits anywhere. It is just a 5 factorial. 5 places are left there and a 5 factorial there, right? So how I am going to write this is a small variation, small kind of change is what we need to consider. Please do it along with me very carefully. Now adding all these contributions of 3 in the number, what do I get? That is my answer. If I am adding all these contributions of 3, add it till here, which is we have 5 factorial, here it is again minus 1. 5 factorial minus 4 factorial is what I start with. And I will have how many 3's? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. When I'm adding all this is what I get that, right? Plus here I start with another 5 factorial with 3 into 10 to the power 5. Clear? That is how I write. Now contribution of 3 is done. Now the same story repeats for 1, repeats for 2, repeats for 3, like that, isn't it? So the same story, if at all I am writing it again, see, 4 factorial into 1, 1, 1, 1, 1, 5 ones with 3 plus 5 factorial into 3 into 10 to the power 5. Now story repeats for 1. 5 factorial minus 4 factorial 1, 1, 1, 1, 1 into 1 plus 5 factorial into 1 into 10 to the power 5. Right? So like this, if I am adding, if it is an n digit number which is formed from the given n digits where 0 is included and without any repetition, how should I start with? Think about and tell me. See, observe, I am given 1, 2, 3, 4, 5, 6. It's a 6-digit number started with 5 factorial minus 4 factorial, right? So what do I get? That I will be taking it like n minus 1 factorial minus n minus 2 factorial into 1, 1, 1, 1, 1 repeated how many times? I am repeating 5 times here because when I have 6 digits, I am repeating 5 times. So I am having n digits, I will repeat n minus 1 times. Clear? Plus, this is again another 5 factorial, that is n minus 1 factorial into n minus 1 times into sum of the digits. I didn't write it here, isn't it? Yeah, sum of the digits there. And again plus another n minus 1 factorial into 10 to the power n minus 1, because when I have 6 digits there, I'll have 10 power 5 there, into sum of all the digits, that is 1 plus 2 plus 3, sum of all digits. This is the form what I get for type 3 when 0 is included and without any repetition. Right? Now type 4 is what I want you to check it out and tell me. What is that type 4? I am trying to bring some 3 digits from some given 5 digits where 0 is included into that. You try out for the type 4 and let me know your answer. Right? Next, what about type 5? So what is it that we are taking to? Now type 5. Type 5, what do we have? Tell me. Now, what is the type 5 for me? Now, type 5 is sum of all the given n-digit numbers formed from the given n digits when repetition is allowed, right? So, I can be able to repeat my digit any number of times. So, 1, 2, 3, 4, 5 digits I am writing with all the given 5 digits is what I am going to play the game when repetition is allowed, right? Now, how do I start with? Now the same story repeats. When 3 is in units place, contribution from every digit is what? From every place is what we are going to count, right? So when 3 is in the units place, it is obviously 3 into, how about all these? These can be filled in all the 5 numbers. Each and every position has a possibility to fill in by any of these 5 digits, isn't it? So here 5, 5, 5, 5. So 1, 2, 3, 4. 5 to the power 4 is what I can take it here, right? So 3 into 5 to the power 4 is what the contribution from the 3 in the units place. Now 3 is in the tens place, that is 30 into 5 to the power 4. 3 is in the hundreds place, 300 into 5 to the power 4. 3 is in the thousands place, 3000 into 5 to the power 4. Now 3 is in the 10,000s place, 30,000 into 5 to the power 4. Now sum of all these contributions of 3 in each and every place is 5 to the power 4 into 3, 3, 3, 3, 3. So that I can consider it like 5 to the power 4, 1, 1, 1, 1, 1 into 3. The same story repeats for 1, 2, 3, 4 and 5, isn't it? So it's 5 to the power 4, the same set of 1, 1, 1, 1, 1 repeated, isn't it? With 1. The same 5 power 4, 1, 1, 1, 1, 1 repeated with 2, repeated with 4 and repeated with 5. Now when I am adding all these, what do I get? I will be getting my final answer to be, I am writing my final answer, that is 5 to the power 4 into 1, 1, 1, 1, 1 repeated 5 times, it is 5 digits, into sum of all the digits. Right? So what is my general notation? When I'm having n digits, I started with 5 to the power 4, right? So I have n digits, n to the power n minus 1 into 1, 1, 1, 1 repeated, so on till n times into sum of all the digits. So if you just know the process only, you can be able to solve it. If you are just remembering its formula, you cannot remember so many things, okay? So try to understand the concept clearly and go ahead. Now, what will be your type 6? So, type 6 will be getting 3 digits, getting a 3-digit number from the given 5 digits. This is what I take. This is with repetition, right? So, earlier case what we have done is without repetition. Now, the case what we are going to do with is with repetition, right? Now, how to pick up the numbers? Now, I'm just giving you yeah. Now pick up a 3-digit number from the given 5 digits, right? So obviously again contribution of a 3 in the units place. That is 3 into, see, as I said, a 5-digit number. We will be having 5 digits, out of which 1 is already fixed there, right? So we are left with 4 digits now for the given 2 places. So is it just 4p2 there, right? Now from here 3 is in tens place, so 30 into 4p2. 3 is in hundreds place, hence it is 300 into 4p2. Together their sum will be 4p2 into how much? 333. So that is again coming to 4p2 111 into 3. The same story repeats here for 4, for 5, for 1 and for 2. Right. So what is its general notation? When I'm starting with a 5-digit number, picking 3 from that, I got 4p2. So hence NPR, so it's like n minus 1 PR minus 1 is what I start with, because this is 4p2. It's not 5p3, isn't it? So n minus 1 PR minus 1, 1, 1, 1, 1 repeated R times here into sum of all the digits is what I get, right? That is my type 6. And type 6 is done. Type 7 and type 8 is what you know. What are type 7 and type 8? That is with the given numbers. If at all you have 0 also included into that case, how are you going to solve that, right? So these 8 cases is what you try and get me the answers, out of which 5 types is what I completed. 3 are only left to you. You do the remaining, right? Okay. Right. Now, next model, what we are talking about is the exponents model, right? See, suppose if I am having a number 3 factorial, right? That is, we know that 3 factorial is nothing but 3 into 2, which is 6. Fine. When I give you a number, a little bigger number, that is 5 factorial. So, what is it? That is 120, right? So, now my question is, how many 2 power values are there? Or how many 2's do you have in this, and how many 5's do you have in this, or how many 3's do you have in this 5 factorial, right? This is my question. So this 5 factorial has got how many 2's as factors? So counting the number of 2's or counting the number of 10's, or suppose if I give you 100 factorial is a huge number, isn't it? It's like 100 into 99 into 98 into 97 into so on till 3 to 1. All this multiplication you will have innumerous number of values which are coming up in these. What is the power of 2 in that? What is the power of 3 in that? That is how my questions are going to be now, right? Like if at all I say, if it is 100 factorial, what is the number of zeros at the end of the given number, right? So for the number of zeros, I just have to think about power of 10 there, isn't it? So that's the exponent model what I'm talking regarding, right? So now try to start with the questions like this. So when I have a number like 4 factorial, we know that it is 24. So it is 2 cube into 3. So the power of 2 is 3 and the power of 3 is 1, or the exponent of 2 is 3 and exponent of 3 is 1. Now when I am talking about a 5 factorial, that is 120, exponent of 2 is 3, exponent of 3 is 1 and exponent of 5 is 10. Now tell me how many tens do I have in this? If my question is how many tens do I have, it is just 1, 2 with 1, 5 combination will give me a 10. So 10 to the power 1 only, right? So next coming with the 6 factorial, that is 720, that is 2 power 4 3 square into 5. Without actually splitting the given number into factors and writing it in this way, I want one such direct answer for all these, right? So directly is what I have to frame. Now how I'm going to do that? Now let me start writing the numbers 1, 2, 3, 4, 5, 6. I keep writing few numbers, right? Right. So I have written the numbers 1, 2, 3, 4, so on till 99 and 100 is what I have taken. Now my question is regarding 100 factorial. Now I am trying to figure out in 100 factorial what is the exponent for 2, right? So 100 factorial has got all these as its factors, isn't it? So now I have to see what will be the power of 2 in this. Now I am going with a bag to collect all the 2's for the first round. First round, all the multiples of 2. I have given 100 numbers, out of which half of them are even and half of them are odd. We know that, right? So first set will be 2, 4, 6, 8, 10, like that, 100, and here you go 98. Okay, so all these, so we will be having how many such numbers? 50 such numbers, right? First round of collecting 2 is done. Now I am going to collect 2 from the second round. I collected 2 from here. See, this is nothing but 2 into 1. This is 2 into 2. This is 2 into 3. This is 2 into 4. 2 into 5. 2 into 6. 2 into 7. 2 into 8, like this we have such numbers. So I have already removed 1 2. I'm just cancelling that out. Check very carefully what I'm doing. I am removing 1 2 from here. Now I am left with 2 3 4 5 6 7 8 and all. Now where do I get another 2? I get another here, my second round. Now second round is what I'm going to go with. Second round of 2 I get from here and from here and from here and from here. If you observe all these numbers, wherever I marked, all these are 2 to the power 2 factors, that is 4 factors, isn't it? 4 multiples, right? So 4, 8, 12, 16. So all these are 4 multiples. So my second round of 2, I will be getting in the 4 multiples, isn't it? So 2 square, how many such 2 square values are there, right? So out of all these 100 numbers, 100 divided by 2 square. This is 100 divided by 2 square. Earlier one is 100 divided by 2. So 100 divided by 4, what will that be? 25, right? So here I got 50. Now for the third round, obviously what should I go with now? You tell me. That will be 2 to the power 3 is what I have to go with, right? So it's again 100. Wherever I have 8, I will find my next 2 there, isn't it? See, this 2 is done like that. I'll be finding my next 2 at the 8 multiples there. Got the logic there, right? So now that will be by 2 cube. So 100 by 2 cube, 100 divided by 8. Now what is it? 100 divided by 8. If I go with 8 ones, 8 and 2 0, right? 2 16 point something. So we will be getting 12, let it be, right? That's the reason why I take step function, in the sense you just have to take the integral part of that. So we are getting 12 from here, and again fourth round is what I start with, that is 2 to the power 4, that is 100 upon 16 step value, right? So like that I have to keep continuing, and what do I get? I will just show you, right? Mm. Right. So 100 by 16 will be 96. So 6 point something. Here I'll be going with the 32, in the sense 32 threes is what I will be getting, 96 and all. Right. So that will be 3 there, and here 600 by 64 is 1 point something, hence it is just 1. Here I won't be getting anything. So sum of all these, that is 50 plus 25 plus 12 plus 6 plus 3 plus 1. These many number of 2's is what we will have in 100 factorial. That is 2 to the power so much of value is what we will be having in our 2 factorial, right? So if the question is regarding what is the exponent for the 3, that is You just have to take 100 by 3, 100 by 3 square, 100 by 3 cube and all step, right? So whenever we want a general notation for n factorial is what I am going with, right? So for this, the power of r is what if at all I am trying to note there. So that is n by r step plus n by r square plus n by r cube plus n by r power 4, so on until you get the step of the value to be 0. That's it. So you just have to add all these and get your answer there, right? Hope you understood this concept. So if my question is regarding exponent of 5 in 100 factorial, what do I go with? 100 by 5 plus 100 by 5 square plus 100 by 5 cube. 100 by 5 cube, 125. That step is already 0, 0 point something. Hence, I will not consider. So what is this? 100 by 5. That will be 20 plus 100 by 5 square. That is 4. So 24 fives is what I have there. Right. Now tell me, exponent of 10 in 100, also I will say that I will be getting 24 only. Exponent of 10 also I will be getting 24 only. Why? What is the reason? In 10, 10 is a combination of 2 and 5, right? So you'll have so many 2's but limited 5's, isn't it? So how many ever 5's are there? That is most important because 2 into 5 should bring my 10 there, right? So now let us calculate that. That is 100 by 10 plus 100 by, just a minute, right. So suppose if at all we are looking for exponent of 10 in 100 factorial, if at all we are applying the same rule 100 by 100 and all, it will not be matching with our flow there, isn't it? This we are getting 10 plus this will be 1. That is it only 11? No, isn't it? This will not be the answer here. See, as we already have five power values to be 24. That means we already have 24 fives. And how many 2's do we have? We have so many 2's. We just now calculated, I guess, isn't it? So more than 24, obviously. How many 2's? It is 50 plus 25 plus 12 plus 6 plus 3 plus 1 2's is what we have. So many 2's is what we have. But my count for 10 is purely for 2 into 5 power only. So 5's, if at all we have 24. Obviously 10 power also should be 24 only, isn't it? Right? So the case will not be applicable if the given number is a composite number. Remember that. So composite number, this rule will not be applicable. Got it? See, suppose if I have 2 power 8 into 5 power 3, how many 10 power values do I have? So it's basically this 2 power 3 into 2 power 5 is what you split into 5 power 3. This becomes 10 power 3 into that 2 to the power 5, right? So 2 to the power 5 is 32, 32 into 10 power 3. Clear? So that is how my logic is regarding this 2 power 8, 5 power 3 in the sense whatever be the 5 power, that will be your answer for the 10 power also. 24 only will be the answer for your 10 power also. But please do not apply the same logic in the formula given to you, that is like exponent of 10 in 100 factorial. No, because that is 10 is a composite number, that will not be applicable as a rule there. Right? So if at all we want 5 power value, do it because it's a prime number. Yes, you can do it 100 by 5 plus 100 by 5 square. All this kept in step and then add them together. Right? Got it? Now, tell me how many of you can try what will be the exponent of 12. Exponent of 12 in the same 100 factorial. Here again, this also is, what is it? 12 is again another composite number what I have given you. So composite numbers will not be working in our direct formula method is what you need to understand. Right? So 12 is a combination of 2 to the power 4 3 is 12, isn't it? So 2 square into 3. Now what I have to figure out is 2 square. What will be the power for 2 square? What will be the power for 3? And then I have to go ahead accordingly. Right? For 2, now I have to start with exponent of 2. That means what did I get? I'll just write the answer. Just a minute. Right, for the exponent of 2, as we have calculated in the earlier case, adding all those 50 plus 25, all these cases, we got 2 to the power 97. For the exponent of 3, what do we get? Let us check. For the exponent of 3, is it 100 by 3 plus 100 by 3 square plus 100 by 3 cube plus 100 by 3 to the power 4 step? That will be enough, I guess, right? So 100 by 3, that is 33 point something, that is 33. 100 by 9, that is 9 ones, 9 1 0, 9 ones, 9 again, isn't it? 9 ones, 9, yeah, 1 0 is what you get. Yeah, 11 point something, hence it is 11 again. This is 27 here. So 27 in the sense, 3 still 4s can I go with? 28, no, 4s I cannot go. So 27 fours, let me try 7 fours 28, 4 twos 8, and oh, it's crossing there, I cannot go. So that will be 3 point something, hence it is 3, and plus that will be 1 there. 100 by 81, that will be 1. So when I add all these, what do I get? 3 4 5 8 along with 3 and 4, 48, right? 3 to the power 48 is what I got, right? Okay, now my question is for exponent of 12. 12 in the sense it is 2 square, remember very carefully, right? So 2 to the power 97 into 3 to the power 48. I have to express like 2 to the power 97. See, as I have to express like 2 square, 97 is not an even number. Make it 96 plus 1. 96 plus 1, right? So that is your 2 to the power 96 into 2 into 3 to the power 48. Right. Now this 96 can be written like 2 into 48. Right. So can I write it like 2 into 2 to the power or 2 square whole to the power 48 into 3 to the power 48. Right. So from here this is 2 into 2 square into 3 whole to the power 48. That is how I got exponent of 12 will be what? 48 is my answer. Is that understood how? So you need to gently get it to that form. 2 to the power 12, you have to split it like prime powers and then manage it very carefully. What is 2 power value? 2 square, that is 4, 4 into 3. Even in your answer, you are supposed to get it to that form and bring it out. Okay now, right? So do it very carefully. These models are very, very important. So in today's class, what did we learn? We have learned the sum of all these 3-digit numbers or 5-digit numbers. Sum of all these heavy numbers is what we have learned, which cannot be done manually without any other support, right? And the exponent of 5 in hundreds also, all this also we cannot do. These are huge numbers which can be solved very easily through the permutations and combinations, right? So good. Go ahead with the upcoming classes. So in the next class, we are going to deal with multinomial theorem. That's a very, very important theorem, very, very important case, what we will be dealing with, right? So go ahead with the upcoming classes. Good luck for your future.